Hello everyone, I'm Simone and ANGELO, a PhD student from the Marche Politecnica University. My 3-year PhD research concerned the possibility of combining different technologies to produce eco-sustainable asphalt concrete. Today I would like to present my latest research about a performance characterization of rubberized wall-mix asphalt for motorway porous wearing course. The presentation will be structured as follows: a brief introduction on the challenges affecting the road material sector, the description of the research and its objectives, the analysis of the results, and finally the conclusions. In the last decades, the pressing growth of road transport systems has contributed significantly to global warming and environmental pollution. In addition, the constant increase of transport vehicles also contributes to the generation of a huge amount of end-life tires to be landfilled. So we are faced with a problem. However, by lowering mixing and compaction temperatures and using crumb rubber within the asphalt mixers, the road material sector can play its part in providing solutions to the global warming. Solution called, in this case, rubberized wall-mix asphalt. In fact, thanks to its well-known economic and environmental advantages, wall-mix asphalt technology, combined with the use of crumb rubber as a modifier of the asphalt mixture, seems to be promising environmentally, while ensuring better or similar performance as compared to the traditional mix. But how can we reduce mixing and compaction temperatures and environmental impact without penalizing asphalt mixer performance? Simply using adequate WMA additives and an optimal content of bitumen and crumb rubber. In detail, according to the Italian motorway technical specification for porous wearing course, the laboratory investigation involved 4 rubberized wall mixtures produced with 4 different contents of total bitumen and 2% of crumb rubber added by dry method. Moreover, the most performing mixture in terms of optimal bitumen content was also modified with 1.5% of crumb rubber, and a warm mixture without crumb rubber was also investigated as a reference. The mixtures were produced at 130 centigrades by using a WMA chemical additive at 0.45% by bitumen weight and immediately compacted at 120 centigrades using a giratory compactor and a Marshall equipment. In this research, the experimental program included about 200 tests overall. Traditional mechanical tests such as Indirect Tensile and Cantabro test, together with the analysis of residual air voids, were assessed to verify the requirements of Italian motorway technical specification and, together with the compaction energy index parameter, to select the optimum content of bitumen. On the other hand, the ITSM test allowed to evaluate the stiffness of the mixtures and so their contribution to reduce the tie road noise. Finally, the most promising mixtures in terms of traditional mechanical performances were also tested with advanced equipment such as a Scuffing-Device to measure resistance to stripping and Wehner-Schulze machine for evaluating skid resistance. In detail, the specimens that have undergone this last test are slabs compacted with a roller compactor. In summary, the objectives of this research were first to verify the possibility of producing in the laboratory warm mixtures with crumb rubber able to meet the specification required for traditional porous asphalt. Secondly, highlight any critical issues to provide indications for future research activities. And finally, select the suitable mixture for the construction and subsequent analysis of a motorway field trial. The results of the residual voids allow to state that at 10 revolutions all mixtures comply with the technical specification. However, at 50 revolutions we have some problems, and only two mixtures, RWP-A and RWP-B, comply with the technical specification. This result is clearly due to the bitumen content, which on the one hand penalizes the residual air voids, while on the other helps the workability of the mixtures, as can be seen from the results of CEI parameter in the right figure for mixtures RWP C and D. The results in terms of ITS and ITC show again that too high or too low bitumen content penalizes the mechanical performance. Furthermore, the crumb rubber content also seems to be decisive. In fact, the RWP-D mixture is the only one which satisfies the technical requirements. However, also mixture RWP-C, although not in line with the requirements, look promising and deserve the further investigation, also due to the different crumb rubber content with respect to the mixture C. Finally, most of the mixtures are not affected by the action of water, showing ITSR value greater than 90% as required by the specification. About stiffness, we can see that the RWP-D mixture has lower ITSM value than the reference one, especially at 10 centigrades, which can contribute to a lower noise level. The results of the Cantabro test show that the most performing mixture in terms of particle loss is RWP-C, but RWP-D is also promising thanks its PL value less than 35% for the wet condition. Moreover, these results are consistent with the percentage of residual air voids shown in the right figure for the Marshall specimens subjected to the Cantabro. So, traditional mechanical tests, volumetrics and workability analysis have made it possible to identify the best performing mixtures, which are RWP-C and RWP-D. Moving on the innovative test, the results of the scuffing device in terms of mass loss per area show, consistently with the residual air voids in the slabs, that the mixture D with 1.5% of crumb rubber has a significantly higher raveling resistance than the mix with 2% of crumb rubber. These results confirm what has already been anticipated for traditional tests. There is a critical threshold of crumb rubber content which can penalize the mechanical and durability performances. In this slide we have the results of Wehner-Schulze in terms of friction after polishing, left figure, maximum FEP value and S parameter in the right figures. The results in terms of FEP allow to state that RWPC mixture with 2% of crumb rubber has performance comparable to a reference hot mixture currently used on the Italian motorway network. The results of maximum FAP allow to conclude that the RWPC mixture offers the maximum skid resistance immediately, and the presence of crumb rubber does not help the polishing of the bitumen. The parameter S shows how quickly the polishing evolves between 50,000 and 118,000 passages. The smaller the S, the greater the propensity to polish. The results shown in this presentation allow to draw some conclusion. First, in the laboratory it is possible to produce a rubberized wall-mix asphalt for motorway porous wearing cures using a chemical WMA additive. However, the bitumen and crumb rubber content can penalize the mechanical workability and durability performance. In this sense, this research showed that the optimal bitumen content is 6.5%, while that of crumb rubber is between 1.5 and 2%. Therefore, even if some results did not meet the specification, it was decided to plan a full-scale trial section on a motorway using both mixture RWP-C and RWP-D to evaluate their performance in situ. In any case, a preliminary phase of setting up of the asphalt plant will be necessary to avoid technical and performance issues. I'm done. Thank you for your attention.